My name is Patrick. I'm here to talk about a topic on physics, measurement of heat energy. Please don't forget to like, share, and subscribe on our YouTube channel at Scholars Card. Good. Now, measurement of heat energy. Now, in the previous lesson, we talked about I define heat energy, heat, and I define it as the flow of internal energy of a body. And I also said temperature decides which way it will flow. So note the difference between heat and temperature. Remember, temperature is a measure of the average kinetic energy of a body or the degree of hotness or coldness of a body. And the unit of heat energy is joules. And the unit of temperature, scientific unit of temperature is Kelvin. Are you getting it? So it flows from a region of high temperature to a region of low temperature. Are you getting good? Now, this time around, we are going to be talking about measurement of heat energy, how we can measure heat energy of a body. Now, when we talk about measurement, we talk about the specific heat capacity of a body or a substance. Are you getting it? Now, what is specific capacity? This is defined as the quantity of heat required to raise a unit mass of a body by 1 Kelvin or 1 degree Celsius. Defined as the quantity of heat required to raise the temperature of a unit mass of a body by 1 degree Celsius or 1 Kelvin. That means the heat content, H, where H is what? The heat content of a body is equal to the mass of the body, which is M, and the specific heat capacity, that's C, and the temperature, that's theta. This is heat content of the body. Heat content of that quantity of it equals to mass of the body times the specific capacity of the body and the temperature of the body. By looking at the body, we can make the specific capacity of the substance by dividing both sides by the coefficient of this C. Are you getting it? Now, mathematically or symbolically, we can say by dividing both sides by coefficient of C, which is which is M theta, we now have that specific capacity equals to quantity of heat all over M theta, change temperature. So this is the specific capacity equals to quantity of heat all over mass times temperature, where this symbol theta stands for the temperature, M is the mass, H stands for the quantity of heat or heat content. Are you getting it? So this is what we mean by specific. Now, every material or substance has its own specific capacity. For example, we say the specific capacity of water is given as 4,000. Specific capacity of water is given as 4,200. Now, the unit of, looking at this formula now, we can get the unit of specific capacity. Are you getting now? Look at the board. The unit of heat, remember, is joules. Heat is a form of energy. We call thermal energy. Unit of mass here is kilogram. And the scientific unit of temperature here is Kelvin. So we can say that joules, when this kilogram is coming on, it will be per kilogram per Kelvin. So this is a specific unit of specific capacity of a substance, joules per kilogram per Kelvin, where the joules stand for energy, kilogram for the mass, and Kelvin per Kelvin for the temperature. So this is the unit of specific heat capacity. Therefore, when I say specific capacity of water, you have 4,200 joules per kilogram per Kelvin. This is specific capacity of water. Is measured standard 4,200 joules per kilogram per Kelvin. Now, you can also ask you to explain this statement. The statement that the specific capacity of water is 4,200 joules per kilogram per Kelvin. When you look at this there, we can say 4,200 joules of heat energy is required to raise the temperature of a unit mass of water by 1 Kelvin. This is the meaning of this statement. It means that 4,200 joules of heat energy is required to raise the temperature unit mass of water by 1 Kelvin. This is the statement. Listen again. It means that 4,200 joules of heat energy is required to raise a unit mass of water by 1 Kelvin. That's the meaning of this statement. Now, apart from water, we have other major units of substances with their specific capacity. For right now, look at this table here. Let's think about, we're taking water. Let's talk about copper. Substance. Copper. Specific capacity. That means that C stands for specific capacity. Copper is 390 joules per kilogram per Kelvin. That's the specific capacity of copper. For aluminium is 380 joules per kilogram per Kelvin. Now let me take for the last one, ice. Ice is given at 2100 joules per kilogram per Kelvin. So these are the measured specific capacity of substances, though we have other ones. Are you getting the standard? So don't forget, its specific capacity is the quantity of heat required to raise a unit mass of a substance by 1 degree Celsius or 1 Kelvin. Good. Now let's go to heat capacity. Heat capacity. Now heat capacity is different from specific heat capacity of a substance or a material. Now heat capacity is defined as the quantity of heat required to raise the temperature of a body by 1 degree Celsius or 1 Kelvin. Heat capacity is defined as the quantity of heat required to raise the temperature of a body by 1 Kelvin. By 1 Kelvin. By 1 Kelvin. That's heat capacity. Quantity of heat equals to heat capacity given as Cp, then change in temperature as the temperature. This is heat capacity. There is no mass in it. Heat capacity of a body. Where H stands for quantity of heat, Cp stands for heat capacity, and this theta stands for temperature. There we can make Cp the subject of the formula, which is heat capacity, by dividing both sides by the coefficient of this symbol Cp, which says Cp, heat capacity, equals to quantity of heat over temperature. Temperature. Now listen, if we have two temperatures, initial temperature and final temperature, which will now be change in temperature, which you use a symbol called delta. This delta means what? Change in temperature of the material or the substance. So this is heat capacity. Heat capacity. Heat capacity. Don't forget, this is heat capacity. Good. Now we can get the unit of heat capacity. The unit of heat are following down now. The unit of heat energy remains joule. It is joules. While the unit of temperature is Kelvin. Scientifically, which is equals to joules per Kelvin. Joules per Kelvin. So this is the unit of heat capacity of a substance. Now let's take a equation. Let's take a equation to verify specific heat capacity and the heat capacity. Now, equation like this. Copper rod, a copper of heat capacity, a copper of heat capacity, a copper of heat capacity, capacity 585 joules per Kelvin. 585 joules per Kelvin is heated until to 35 degrees Celsius until it rises. The temperature rises to 85 degrees Celsius. Calculate the quantity of heat. Calculate the quantity of heat and the mass quantity of heat of copper and the mass of copper. Now you take the specific capacity of copper, specific heat capacity of copper. Copper, C stand for copper as 390 joules per kilogram per Kelvin. Look at the equation. A copper of heat capacity 585 joules per Kelvin is equal to 35 degrees Celsius until the temperature rises to 85 degrees Celsius. Calculate the quantity of heat required and the mass of the copper. Now look at this solution. Now you have to write out the parameters given to you there. Write out the parameters given to you. We have the heat capacity. The heat capacity of copper is given at 585 joules per Kelvin. And change in temperature, that's 85 degrees Celsius minus 35 degrees Celsius. This means that the initial temperature is 35 degrees Celsius, while the final temperature is 85 degrees Celsius. That's the final temperature minus initial temperature will give you the change in temperature. And you are asked to calculate the quantity of heat, that is H, the quantity of heat, and you are given the specific heat capacity of copper. Specific heat capacity of copper as 390 joules per kilogram per Kelvin. Are you getting it? Per Kelvin. Now let us first of all calculate this one. Look at what the parameters here. Quantity of heat equals to what? Heat capacity. Heat capacity times change in temperature. Time change in temperature. You are given it, therefore we have that quantity of heat equals to, we have the capacity which is 585 multiplied by change in temperature from 85 minus 35 degrees Celsius. So we have that 585 times, now 85 minus 35 will give you 50. Therefore we have 29. When you multiply 585 times 50. Now let us calculate 585 times 585 times 50 will give you 29,250. You don't leave it like that. You make sure you put the unit of heat. The unit of heat energy is joules. So that is the quantity of heat. The quantity of heat required to raise the temperature of a unit mass of copper given this heat capacity. Are you getting it? Now let us calculate the mass. We are also asked to calculate the mass. We are also asked to calculate the mass. Are you getting it? Also calculate the mass. Now to get the mass, you apply the formula for heat content, specific capacity, which is mass times the specific capacity times change in temperature. Here we have to calculate the mass, where M is the mass. We have got to calculate heat content or quantity of heat. And we have the specific capacity of copper. So you just make M the subject of the formula by dividing both sides by the coefficient of M, which is C, C change in theta. So we have M mass equals to heat all over C, specific capacity times change in temperature. So we have the mass here as we have gotten this at 250 divided by specific capacity of copper is given to us as 390 joules per kilogram per Kelvin. 390 multiplied by change in temperature 85 minus 35, which is 50 here. Now let us do it. 390 multiplied by 50, we have 19,500. The mass equals to 29,250 divided by 19,500. 19,500. 29,250 divided by 19,500. So we have the mass at 1.5. So the mass of copper is 1.5 kilogram. 1.5 kilogram. I hope you enjoyed this teaching. Please don't forget to like, share, and subscribe on our YouTube channel.